Now that we covered the main examples that we're going to go over in class and the main categories of learning that we're going to do, I wanted to make a short video that answers what is most students' first question, which is how do I succeed in the class? How do I succeed in the machine learning class? The first thing I'd like to do is to acknowledge that people have lots of different goals and mean lots of different things by success. So one student might mean I want a great grade. That's one idea of success in the class. Another student might say, I want to learn as possible. Another student might say, I want to looked. Sure. Like, another student might say, I want to earn some specifics. How that works. All these students have different goals. And so I can't give a general purpose idea about how to succeed at all these different goals. I think that it's very important that each student individually kind of sit down and think a little bit about what they want to get out of the class. However, what I can tell you is kind of how the class is laid out. And when I give you my structure of how I've thought about the class, how I've structured the material, the assignments, and the learning objectives of the class, what I hope is that you'll be able to take your own goal, look at the way that the class is structured, and figure out a smart way to achieve what you want to get out of the class. People have different goals for different reasons. I don't know everyone's background. Someone who has a lot of background in machine learning, the I want to get a great grade role might be pretty easy to them. Maybe that means they focus on it. Maybe that means they don't focus on it. I'm not sure. This is too complex. So let's just look at how the class is laid out. And I think that'll help everyone to kind of answer their own, how do I succeed question. Right. So I'm going to jump over here to the syllabus really quick. This is our class syllabus. Here are our course objectives and learning outcomes that we are particularly interested in. This is divided kind of roughly into two halves. The first half is this half that we talked about in the first video about machine learning knowledge and skill mastery. The knowledge being predominantly captured by this first learning objective, what I call ML explanation. I want you to be able to clearly articulate the machine learning systems, algorithms, and techniques that we are studying. I want you to use appropriate oral and written descriptions. I want you to be able to use mathematical notation and to produce visualizations for your output. That is a way of communicating your knowledge to me. If you have that knowledge, I expect you to be able to demonstrate that knowledge by communicating it to me. On the other side, we also have ML code. This is more on the skill mastery side of the equation. I want you to produce working, readable, and performant Python implementations of a wide variety of machine learning systems using appropriate libraries and appropriate software tools like GitHub and Jupyter Notebooks and so forth. If you are able to understand the stuff, that's one good step. But I actually want you to be able to deliver that stuff and actually produce working code as well from your knowledge of it. However, that is only 50% of what we're going for in the class. I also want everyone to do is to produce original machine learning work that goes beyond the scope of what was covered in class. Now, this is a little bit of a weird thing. This is, most classes, the point of the class is like, we're going to cover this body of knowledge and we've got we draw a circle around the class and everything inside that is fair game and everything outside that is, we're not going to talk about it. That is actually a very poor way to teach machine learning. Machine learning is a very rapidly evolving field. There are new algorithms and techniques coming out all the time. I hope to be able to give you a solid foundation, but that solid foundation is only half of what you will need to actually be a master of machine learning and actually use it in practice. In practice, you will have to be able to learn new skills. You'll have to be able to take the skills and apply them in diverse contexts that you did not study in your class. And so if you are unable to flexibly apply your machine learning skills and develop stuff over time and set up good systems for yourself, I have failed you as a machine learning instructor. And so I wanted to give half the course to kind of weight toward these going beyond the scope of what we covered in class. There are two learning objectives here. The first is ML flexibility. This is the one that I think is the thing that first comes to mind, which is reason flexibly, apply information in new contexts, produce novel work, and articulate meta knowledge about machine learning. So be able to say, oh, this model won't work because it's overfitting in this way. Or I have a great example of this, which is often students will be able, I will ask a student a question like, okay, why wouldn't you use a regression model here? And the student will think about it for a little while, and they may not be able to exactly articulate why you wouldn't use this specific regression model in this specific context, but they just kind of know there's something wrong about it, right? Like the data is labeled data. So it's like, how do you regress, labels of cat and dog or something like that? That actually shows some flexible meta knowledge about that the student has integrated in their mind. I want to give them an incentive to develop that, to not just be able to say back to me what they read in the textbook, but to be able to think about how the parts move and work together and fit together. That's what this ML flexibility objective is mostly for. The second one here, the ML development one, is a more subtle way of going beyond what we cover in the class. So I'm going to provide to you what I consider excellent resources to understand a particular algorithm, to, there will be good readings from this book, Probabilistic Machine Learning, that is the kind of our major text for the class. I will endeavor to get appropriate videos for each of the different algorithms. I will endeavor to have some kind of supporting examples and some problems for you to work, the problem sets for you to work through. That's all very well. However, I expect each and every student, when they do the pre-class work, to take notes on what they studied and to compile a study resource, ideally on a Notion page. That's the way that I would like it shared, that covers what they did. You need not do this alone. In fact, I would prefer if you didn't do it alone. I'd prefer if you created a common page with a study group of about 3 or 4 friends, and you all contribute to it, and I get to see your posts and comments and your materials. I would like you to share that widely with anyone else in the class. I would like you to dump everything into one big blob where everybody compiles all their study materials to create these excellent and ever-evolving and improving resources. I'd like you to critique it and edit it as if it were Wikipedia, cutting out things that you think are, it's a good idea, but maybe let's move this to another page. Let's move this to a sub-page where it's like, optional or supplemental material. I want you to kind of develop those resources. In addition, I want you to have a GitHub repository where you keep track of all of the code that you write in the class and you check in things and update it. This ML development thing, therefore, represents you taking actual agency and control of your own learning of machine learning to develop resources that you can use later, that you can refer back to, and to develop the artifacts both in written documents and code that you will later use. One of the major things that makes you get better at machine learning over time is that you are building algorithms and that you retain the codes of previous algorithms. You will go back to your own work, take snippets of codes and bring it forward. If you solved a problem, usually a problem with data flexing or feature engineering, at one point, you will probably adapt or at least study the code that you used before to create your new solution. You're building on top of stuff. And so if you are not curating these learning materials and code base that you are pulling from, you are in a much worse position and much less able to do machine learning. When you leave this class, I expect you to take this Notion page with you. I expect you to take this code with you so that you can, as you go out in the world and get future jobs and work in future classes and understand things, build on what you know. There is not enough room. You cannot commit machine learning to memory. It is in part an artifactual discipline. It relies critically on technologies and external knowledge sources. And so I want you to build those external knowledge sources. And if you haven't, you are in a dramatically worse position. And so I'm actually going to reward you for doing it. Now, the way that this will work is these are the 4 core ideas that I want you to learn. So how to actually implement how you're going to study these. Well, let's look at the assignments and score calculation. All right. So there are only 4 assignments in this class. They are a location-based assignment. You'll get this pretty close to the first day of class. It'll come out. And the reason for that is it requires some data collection. You will need to go around and take photos of monuments and places at different times in the city that you're in. And so you need some time to collect that data. So it goes up immediately and it's due at about mid-semester, a little before mid-semester, about 5 weeks in. The final project, which you'll also get right away, is to create an original implementation of machine learning. It is very much in that ML flexibility category. I want you to go out and find some problem that we didn't address in class or some missing library that is out in scikit-learn. And I want you to implement something that we did not cover from soup to nuts. Just do the whole thing from data collection, data flexing, metrics, training new algorithms that we didn't cover. Go and learn a new thing. Show me that you can take the core skills that we developed, the foundational skills we can develop in this class and deploy them. You have the whole semester to do this. We will check in with this several times throughout the semester during class to make sure that people have picked tractable final projects and have started working on them and doing the thing. We will tend to start those a little bit after the LBA wraps up. And now everything else in the class, I think, including these other 2 assignments, the corrected problem sets, all of these actually run through work you do in class. They are all pre-class work related. Every time you sit down for a class, you will have a pre-class work. You'll have a piece of pre-class work to complete for each and every class. Typically, your piece of pre-class work will look like, here's one. It will look like a code notebook like this. It will be attached to your class and it will run, you'll have it till the class begins to turn it in, right? What you can do in that is there'll be a couple of exercises, usually from the textbook or from the repository of code problems. These will show up here. You have access, incidentally, to all of these in the GitHub repository beginning at the very beginning of class. They're all in here. All of the problems you'll see. You can start working on it from everything in the class from the first day, if you so desire. But they are metered out and they are nicely spaced in time so that you can get space practice on them. You'll get about 2 problems every class. You will have an opportunity to work through those problems and give your responses, turn them in for pre-class work. And at the bottom, I want you to link your studying materials, your Notion that you use to study stuff, any videos that you found, anything useful, any materials that were particularly helpful, alternative readings, alternative code implementations, online visualizations, all of this stuff. I want you to link that as well as part of every piece of pre-class work. So you'll be judged both on, can you get these couple of problems right? And also the materials, the study materials that you build to show me, right? Now, because that is now to me, this steady work and this production of materials and code snippets is so critical that your pre-class work accounts for 25% of the entire course grade. It's the same weight as your final project. And in fact, this daily work may even end up feeling a little bit heavier because there are stuff like poll responses and verbal contributions in class, which will also be evaluated on, ML expression and ML or ML explanation and ML code. But so there's more in-class stuff, right? So that pre-class work stuff, which prepares you to do well in class, is also evaluated in class. And secondarily, twice during the semester, once at about midterm and once right at the end of the semester, I will be accepting a corrected problem set. So what this means is if you didn't, we all have problems, we all run out of time, we all get sick and things like that. So if there was something that caused you to miss a pre-class work or to turn in work that you don't feel like is up to your full standard, you have an additional opportunity to turn in all of the problem set again, having made any corrections in the interim that you wish. So you can upgrade your grades in kind of the pre-class work by turning in this corrected problem set. It continues to contribute positively to the class. The corrected problem set has nothing new. It only has former pre-class work problems that you now have the opportunity to really expand and stretch out. Again, because I am evaluating you on how flexible you are and how much you're able to go beyond the material of the class, these corrected problem sets are an excellent time to take those pre-class work problems and maybe do the optional sections of them, or maybe expand them and improve them in ways that you have learned since then. That sort of thing is what I'll be looking for in order to give, that tends to result in higher scores when I see those, that you've kind of expanded those during the corrected problem set. So to put this in a nutshell for you, what you really need to do to succeed in this class, the places that I'm really evaluating for credit are, first, I want you to be able to explain clearly and clearly articulate what you have learned. All right. This means both verbally, in written text, and with mathematical notation and visualization. I want you to be able to tell me what you've learned. I want you to be able to code it and get it to work and run and give you the answers. I want you to be able to reason flexibly and to be able to apply information in new contexts. I will largely be looking for when you put, the way I will evaluate that is, can you provide me with stuff that I didn't give you in class or that I didn't give you in the readings? If you cannot provide me with things outside of it, you may do very well in these core machine learning skill mastery objectives, which may be your goal. And maybe that's your whole goal. And I think that's a fine goal. And I'll never judge anyone for any particular goal that they have in the class. I'm just saying, it'll be harder to get these flexibility points if you're really focused on what I provide you. And finally, I want you to be kind of growing a garden of social connections with a study group of your peers that you work with, a garden of little code resources and snippets that you will use in future, and a garden of, study materials that are kind of reworked to work for you. So I want you to be building this document as we go through the class that really is, this is what I studied. This is what I learned, right? I want to see the results of your processing of the knowledge. I want to see you making compositions and kind of collages of the material that you used. If you do that, that really shows me that you interacted with the knowledge, worked with it, and thought it through. It's really good evidence of learning, right? So that's the core things I want you to do. And the ways that they're going to show up in class is mostly in this pre-class work. So I would say, one of my hobbies is board game design. And one of the things I think is really good when you're teaching someone the rules of a board game is you should tell them how to win. And you should tell them kind of what to do on their turn, what to do every time they have to make an action. Right. And so I think give them kind of a good strategy. It may be more complex. They can learn the complexities later. So I want to tell you how you win in this class, right? The best way to win in this class is to really focus on that development objective, really focus on curating a list of resources on learning flexibly and broadly. That means doing all the readings that are assigned. It means going through all the materials and doing all the practice problems there, but it means not stopping there. It means considering that to be the introduction of the materials. And the real work is reorganizing it in your own brain, explaining it to each other, and developing materials that are reusable in future classes. As long as you're doing that and continuing to build on stuff, that is how you win in the class. Almost everything you do in the class is going to flow out of that development document that you're building. All right. All of your class, all of your code, snippets and assignments and everything, they find a home in that development document and they will later be expressed. So do that development. That's how you win at the class. What you do on your term, the thing you should be focused on class to class, day to day, week to week, is really focus on that pre-class work notebook. Do a great job on it. Think through it. Some of these problems are quite hard, and I'll talk a little bit about that in a second, but stick with them, work through them, try to get unstuck, try to figure them out. They are intended to be challenges so that you can kind of struggle against them. And by, succeeding at them, feel good, feel like you beat something pretty hard. I often use the analogy last year of like fighting a boss in Dark Souls, right? It's incredibly difficult. The point is for it to be incredibly difficult. The point is for it to require a lot of special knowledge and special execution and understanding, and to really get a good read on it and to really understand it deeply, not just to kind of mash through it. It requires, you are intended to fail many times at these pre-class work problems. And that's okay. Like, fail many times at them. It's not a big deal. You'll get them eventually. And then when you succeed at them, it will feel a lot better. And I will know that you've learned a lot because they are quite difficult. Okay. So very briefly, those are two things. How do you win? Hey, just keep developing your garden of materials and study materials and code and friends and so forth. How do you succeed day to day? Really focus on that pre-class work. Get that pre-class work done. I really recommend doing at least two such, scheduling on your calendar a session where you do your first pass in the pre-class work, and then that second pass in the pre-class work right before class. That first pass should be well in advance of the next class, because by the time you get to the next class, if you do get stuck, there's not enough time to get unstuck. And so I really recommend doing those two things. So really focus on that pre-class work. Those are the two things that are critical to get you through here. Okay. So to wrap up, I really want to say that this class has a little bit of a reputation for being quite difficult, and that's well earned. And it's because machine learning is quite difficult. There's no way to get through it. Primarily, it feels difficult for those reasons that I outlined in that second course objective, that it requires you to kind of go beyond the knowledge. It's all about, machine learning is about the core idea of machine learning is that we want to bring about some function. We want to do some, I want a machine to do some kind of function, right? But we don't know what the function is. We can't write down exactly what to do. Instead, we have many examples. And the machine, we have learned systems, we have learned mechanisms by which we can get machines to look at the examples and make reasonable guesses, go beyond those examples, make reasonable guesses about what the underlying function might look like, right? That is what I want you to do in this class as well, right? I want you, that requires a lot of practice. It requires a lot of examples, diverse knowledge. It requires getting things from many different sources. These are all things we'll talk about in overfitting. There's all things we'll talk about in, how to get good training in machine learning models. I want you to do the same thing. All right. That the more data you have, the more broadly you apply it, the more you practice it and reorganize it and train on it, the better. All right. And this is kind of the thing that ties them together is that, is that unfortunately, no one can be told what machine learning is. You have to experience it for yourself, right? This is not a class that is solely knowledge driven, and it's not a class where everything can be written down. I want you to go and try and get stuck at things. I want you to try to unstick yourself at things. I want you to reach out to peers to try to get deeper understanding. And I don't want you to just try to get to the answer of things. I'm providing a lot of flexible and odd questions that require you to show me some level of creativity and some level of depth of knowledge in the implementation of answers. And so I really want to see that level of self-expression come out in these machine learning implementations. That's the way that I've included a lot of these learning objectives because I will require that flexibility in order to get a good grade. I will require that thinking beyond just the core data. I'm going to give you a great start. I'm going to give you really thoughtful, flexible, solid base machine learning knowledge, but that knowledge is not what machine learning is. Machine learning is taking that knowledge and recombining it in flexible and interesting ways. And the only way to do that is through effortful practice, through social support, through curating a little garden, and through thinking of this project not as I need to get a good score on this next pre-class work, although, focus on the pre-class work, try to keep up day to day, but ultimately think much longer term. Think about the class as a whole. Think about learning these materials and mastering them, and demand of yourself clear thinking on these topics. The one of the most common ways to get stuck in this class is to complete the assignments, complete the pre-class work, and feel like you kind of know what's going on, only to get the next algorithm that's building on top of this, the next block of linear algebra, the next learning algorithm, and find out that there was depth to that knowledge that was implied by that previous topic that you haven't yet mastered, right? And now it's the time to master. So lots of practice, lots of failure. That's a good thing. The point is to kind of beat your head against these problems over and over again until you succeed. I think that one of the things that I really encourage you to do, and I'm going to, we'll talk about this when we set up class, is find yourself a study group, start building your kind of document right now. I want to give you conclude by giving you a very quick example that one of my student interns this summer produced. This is for an algorithm called XGBoost, which is which is a very, very powerful classification and regression algorithm that's used in a lot of everywhere, forecasting, all kinds of stuff. It's a tree-based method that uses boosting and gradients to figure out to do classification and regression. So it's a Shikeha, and she went around and asked her, find me, make me one of these documents, make me carry me some resources on XGBoost. So she found some prerequisites. She made some notes on it. Here's a Notion, an Oracle Catalyst she found very useful. Here's a link to some of the sub algorithms that are part of XGBoost. It is an ensemble model. Here is a book that covers gradient boosting with scikit-learn. Here is some code resources and some data resources. Here is a tutorial. This is Machine Learning Mastery from David Brownlee, who's one of my favorite machine learning developers online, about how to do XGBoost. All right. So here are a bunch of resources. All right. This is obviously still incomplete and needs to be edited and needs to be contributed to by other students. But this is the sort of thing that, look how much better you would be able to do XGBoost if this was what you did for your pre-class work. All right. This is the model of what you do. Every time we do something, this doesn't take 10 hours, right? It takes an hour or two. And every time we study a new algorithm, I expect you to go beyond the reading. We're not trying to decode the readings. You're not trying to just understand what's there. You're trying to build something like this, something that really works for you. And that is the way I think that you will be best able to succeed in the class. And I've set up the grading and the assignments so that this is supported. This is an intended activity. The more that you do this, the more you curate it, the more you build resources for yourself and your peers, the happier I will be and the more successful, the better you'll do in class. All right, that went on a little longer than I intended, but I think it is stuff that is critical to kind of understanding what the course is going to look like. If you watch one video and really want to understand how the goals of class, it's probably going to be this one. I'll see you in the next one.